Functions are one of the foundation of math, especially at more advanced levels. Still, it is something that we face and deal with every single day. From shopping to setting an alarm for school, we use functions in real life all the time. If you want to learn programming, math, physics, and basically anything, you should be able to work with functions and know how to implement them. This is a list of contents and subjects that we are going to teach in this video. Functions are tools that do some things for you. For example, this box could be a function. Each function has an input, which is the thing that you provide it with. This input can be data, knowledge, or physical objects. And they also have an output. The function will take the input, modify it in some way, and then return the output. Your microwave is a function. It takes cold food, input, it warms it up, work, and at the end it returns warm food, output. Eyeglasses are functions. They take light as an input, they concentrate them towards your eyes, which is the process, and at the end they return the light concentrated to the correct part of your eye. If I wanted to name functions that are present around us, I literally couldn't stop. Functions in math are the same thing, but they work with numbers and values. For example, a function in math can get 3 as the input and then multiply by 2 and give 6 as the output. Before we start to learn their notations, we should learn their properties. Learning these properties help us identify functions easily and learn our way around them. 1. Every input must have one output. Different inputs can have the same output. For example, if I have a function that squares the input that I give it, if I give -3 and 3 to the function, two distinct inputs, I will get the same output, 9. This can't be true the other way. It means that each input must have only one output. You cannot give a number like 3 to a function and get 7 and 8 as a result. 2. Functions are predictable. This means that once a function returns an output for a certain input, it will always return that output for the same input. It is because of the first property that we explained. 3. Domain and range. In math, we call all the possible inputs domain, and we call all the possible outputs range. These two are very important concepts and terms that we will use a lot, and we will have to get back to them further in the future. These are not the only properties that they have, but they can help us get started on more advanced topics and help us better understand how functions actually work. In order to learn functions in math, we first need to learn how they are represented. Functions can be represented in different ways. The easiest form of functions are mapping diagrams or arrow diagrams. In the mapping diagram, you will have two sets of values, domain and range, or input and output, on two different sides. To make it look good, I always wrap them in an oval type of shape, like this. Each item in the input has to connect to an item in the range. Remember that each input can only connect to one output. So, only one arrow always leaves from one input. This is a function, but this other one is not. These are some examples of arrow diagrams. Determine which of these 6 diagrams are functions and which are not. Then, we have the table of values as a form of functions. This one is very similar to the arrow diagram, but it is represented as a table. This is an example of a table of values. On the left, we we have different inputs, and on the right, we have the output that they give. For instance, if we give 3 to this function, we will get 28 as our output. The same goes for this form as well. 2 separate inputs can give you the same output, but a single input can't give you 2 outputs. Then we have graphs of functions. You will be working a lot with graphs when it comes to functions, as they are the best way to visualize a function, and they give us a lot of data about them. The graphs of functions are drawn on a coordinate plane where the x-axis is representing the domain and the y-axis is representing the range. You can find out if a graph on the coordinate plane is representing a function or not using a simple test. You have to draw a complete vertical line at any point of the function, and it has to touch the graph 1 time or less. If that vertical line touches the graph twice or more, then that graph is not the graph of a function. You have to do this test for every single point on the graph, and it has to be true at every trial. Well, doing that would technically take forever. In reality, you don't have to draw any lines to see if it is a function or not. You just have to look if there is any point where if you draw a line, it will intersect it twice or more, and if yes, then that is not a function. When you look at the graph of a function, sometimes you will see a circle at the end of a line or a curve. If that circle is filled, it means that the point is included. The function actually exists at that exact x value. But if the circle is hollow or open, it means that the function doesn't include that point. It gets close to it, but it never actually reaches it. We use these circles to show whether an endpoint or specific value belongs to the domain or not. There is one additional representation that we need to learn, because when we get to graphing, we would need this representation. It is called ordered pairs. In ordered pairs, you have 2 values, x and y. They are in a parenthesis and a comma is dividing them. The x value is showcasing your input and the y value is showcasing your output. The order matters here. The x has to always be on the left and the y has to always be on the right. This x and y can be x and y of a point. In graphs of functions, you can put the domain as the x of the point and the range as the y of the point. And most importantly, each function has an equation. Equations are the most common way that functions are represented. Each equation consists of 3 elements: the name of the functions or the function symbol, the independent variable or the input, and an expression. The name of the function could be anything. However, the most conventional way to name a function is using single letters such as F or G. Then we have the independent variables. X is mostly used to name this variable. Still, you can call it anything you want based on your function. This comes in the same side of the equation as the name, and it will be in parentheses. At the end, we have the expression, which is the process that the input has to go through before giving us the output. This part comes on the other side of the equation, though the general formula would be like this. Let's see some examples. If I have a function with the name f that takes x and adds 2 to it, the name of the function will be f. The input is x because it is going to take x and do something with it. And the process is the work, is the thing that we're going to do with it. In this case, it's adding a 2 to whatever our input is. Our input is x, so we're going to add 2 to x. So it is x plus 2. So as a result, we will have this equation. The correct way to read the final product is f of x is x plus 2. Second example, I have a blender that can make 1 cup of banana milkshake per 2 bananas that you blend in it. So the name of the function can be m because the output is milkshake. The input name can be b because it's the number of bananas. The process is giving out 1 milkshake per 2 bananas. So the formula will be bananas divided by 2 or B divided by 2. As a result, we'll have M of B is B over 2. For example, if you have 4 bananas, you will have 2 banana milkshake as a result of blending. This will give us the equation for a function. Now, if you want to find the output for a specific input or knowing what inputs give a desired output, you just have to substitute. For example, if you have f of x as 2x, you should be able to find f of 3 by putting 3 as x in the expression. So 2 times 3 is 6. You should also be able to find f of negative 3, which is negative 6. You should also be able to find f of 1, which is just 2. Let's look at this one as well. G of x is equal to 3x over 2 plus x. We see that in the expression, x has came twice. We don't care how many times x is written in our equation. Anytime when you want to give the input to the function, you have to substitute that input anywhere that you see x. For example, here we have to substitute x twice. Now, what if I tell you z of x is equal to 3x? If z of x gives me the output of 9, what input have I gave to it? This one, the output is already provided and we are asked to calculate the input that results in that output. You have to set the formula equal to the output. So you will go 3x is equal to 9. And then when you solve this equation, you will end up with x equal to 3. Have in mind that each output can be resulted by different inputs. So you may find 2 answers when finding the input. Like, if f of t is t squared, find t when f of t is 4. In this case, you will say t squared is equal to 4. So t is the square root of 4. The result of that is both positive 2 and negative 2. And that makes sense because 2 squared is 4 and negative 2 squared is also 4. So we saw that one output could have 2 inputs. Functions are very important. They are everywhere from your math textbooks to actual real-life objects and scenarios. Learning them can help you excel both in your math classes and also gives you a very powerful tool. This video was the first video of a series about functions. In the future videos, we are going to dive deeper into the world of functions. So, if you want to learn more about them, make sure to check out our channel and the function playlists.